Group Case Study Checkpoint 2 by Suyun Chang, Caleb Dye, Avery Fry, Brittany Gear, and Philip Goldberg. Our main objective through this statistical research is to solve the research question of do factors such as rate of population without a high school diploma, unemployment rate, population under the poverty rate, and police on patrol rate significantly impact crimes per 100,000 population for varying urban areas. Our null hypothesis is that there is no relationship between crimes per population and the predictors, and our alternate hypothesis that is at least one predictor explains variability in the crimes per population. So looking at our initial MRR model, we have a response variable, which is the combination of violent and nonviolent crimes per 100,000 population for varying cities in different varying parts of the country. Our predictors are percentage not high school graduate, percentage unemployed, percentage under the poverty line, and percentage of police on patrol, which are combined into our MLR model for a sample size of 266. Looking at the resulting R output, there are many interesting phenomena that can be looked at. The first is the negative residual, which implies that the predicted values of crimes are actually larger than the reality of the situation for varying cities. Another interesting fact is that for the response variable, there's a fairly large standard error for crime prediction, which could exemplify the large variance of results for different cities and that some could possibly have an exaggerated impact. There's also an interesting variation of negative and positive impact of the predictors on crime rate, which is interesting considering 3 of the 4 factors have a negative connotation. You could see that percentage not high school graduate, unemployed, and population under the poverty rate, you would expect through general understanding to have an increase in crimes, but there seems to be a variation there in our MLR model, and that will be discussed a little bit more later.
Hello, my name is Brittany, and I'll be talking about the coefficients for our MLR model in context. So on the left side of the table, we have the 5 different coefficients, the intercept being B0, percent not high school grad being B1, percent unemployed being B2, percent population under poverty being B3, and Lemma's percent police on patrol being B4. So for B0, we have an estimate of 4,900.285. So when all of the predictors are held at 0, the crimes per 100K population is expected to be 4,900.285. For B1, we have an estimate of negative 41.723, and the interpretation for this is when we're holding all of the other predictors constant, each 1% increase in population without a high school diploma is associated with a decrease in crimes per 100K population of about 41.723. And then for percent unemployed for B2, we have negative 126.069. Holding other predictors constant, each 1% increase in unemployment rate is associated with a decrease in crimes per 100K population of about 126.069. For percent population under poverty, which would be B3, we have 335.109. When holding all other predictors constant, each 1% increase in population under the poverty rate is associated with an increase in crimes per 100K population of about 335.109. And then finally, we have Lemma's percent police on patrol with an estimate of 1.432, so that would be B4. When holding other predictors constant, each 1% increase in police on patrol rate is associated with an increase in crimes per 100K population of about 1.432. So we can see here that some of these have varying degrees of effectiveness. The Lemma's percent police on patrol only being a 1.432 is a very small increase. So even if they are linearly associated, the increase is so small that the slope is so low that it's barely even worth anything. Um, on the other hand, the percent population under poverty does actually show a decent high estimate, each 1% increase in population under poverty being associated with 335.109 increase in crimes. That's a fairly big effectiveness.
Okay, hello, my name is Caleb Day. Here I'm going to present the initial model along with the regression output and then comparing it with 2 other SLR models. Unfortunately, my camera is not working for some reason and can't change my name, but that's okay. Anyway, so you can see we have our initial model right here, MLR model in this case. We have our crimes per population as our Y variable, percentage of not, high school grads and then our percentage of unemployed, percentage of population under poverty, and then the percentage of police on patrol. Those are X variables in this case, with crimes per population as our Y variable. Sorry, the rest being our X predictor variables. Same as usual with any other MLR models. Now, as you can see, the regression output for this MLR model, we could see that from this are like, you know, the coefficients are like kind of like all over the place. We have like two negatives here for percentage of people, not high school grads, percentage of unemployment, both negatives, percentage of population or poverty, and then police, on patrol. It's both positive. Intercept is really large. Standard deviation for the estimate, everything for the intercept is pretty large. And we could see that from the, you know, p-value, uh, only about the intercept and then percent of population on poverty seem statistically significant. The others don't really seem as much. Uh, Looking at the R squared, we can see that, oh, okay, this has 0.412. And I mean, it's not really that good, but it's not really that bad here. It's kind of like in the middle when it comes to like how good the model represents the data. So it's kind of moderately well, but not as good as we want it to be. Anyways, now comparing it to two of our SR models we did before from checkpoint one, comparing it with the percentage of police on patrol and then with percentage of population under poverty. For this one with the lemmas, like police, percentage of police on patrol, we could see, okay, uh, the R squared compared, the R squared of this SLR model compared to the MLR, pretty low. Okay, this is a very small R squared compared to the 0.41 of the MLR, very tiny. We could also see that the estimate from before is negative. Well, from this SLR, whereas from before, the percentage of police on patrol, it was positive, but in this case, it's negative, and also it's still statistically it's not statistically significant in this case, even then. Uh, and then comparing it with the MLR to the percentage of population under poverty, we could see that the R squared for this SLR pretty close to the MLR in this case. Very similar, almost close to the 0.41 for the MLR. This case still statistically significant for the percentage of population under poverty. However, the coefficient estimate for the X predictor variable is a little bit different from, well, lot different from the MLR, like coefficient estimate for the percentage of population under poverty. In this case, if you look at the previous case, it's a little bit larger, so 335.109, whereas in this case, it was a little bit lower, a little bit smaller, but that's okay. Now, let's just go on with Suyan comparing the other two SRR models to the MLR. But thank you for looking.
Okay, now looking at the other two variables in the MLR model, we have the percentage who have not graduated from high school and percentage who have been unemployed. So in the SLR models for these two variables, both unemployment and high school dropout showed positive associations with crime, meaning higher unemployment or dropout is linked to higher crime rates. However, in the MLR model, after controlling for other variables, both coefficients turn negative and become smaller in magnitude. And in the SLR, each predictor alone captures both its own effect with the crime rate percentage and had a very small p-value showing strong evidence in linear association. However, when we adjusted these two variables into the MLR model, we expect that poverty, which had a very high significance in the model, the unique contribution of the unemployment or dropout may actually become negative or statistically insignificant. And although the VIF values are small, they don't explain the overall overlapping correlations. And through MLR, the model isolates the unique contributions by fixing the poverty, which had the strongest correlation, and observes the unemployment or school dropouts unique contribution, which might not be as strong. And also from the SLR, with individual predictors, their R-squared values only explain 10 to 70% of the crime variation, while the MLR model with the 4 variables increases the R-squared values to 41%. And this means that the multiple variables are suitable to capture the overall variations, and thus the MLR model is stronger than the SLR model.
So next we want to really look into multicollinearity and look for any issues that might be causing in our MLR model or that we might find down the road, looking at things like confidence intervals and prediction intervals. So first, just before we even look at VIF scores, we wanted to make a correlation matrix, just see what kind of correlations there were between our variables, and use that to kind of tip us off on if there might be some multicollinearity issues. Looking at this correlation matrix that we made, we see that there's some decently high correlations, nothing super high enough for us to be thinking that we're 100% like going to have multicollinearity issues. But we do see some 3 at least high R-squared scores, a 0.778 for the relationship between percentage of people unemployed and the not high school grads. Another 0.782 for percent population under poverty and percent unemployed, and 0.66 for percent population under poverty and percent not high school grad. So these are moderately high positive relationships. So we'll have to look at the LEMAS percent police on patrol does not seem highly correlated with any of the other ones. So we seem to be pretty confident that we shouldn't have any problems with multicollinearity, at least with that variable. But we are going to use VIF scores just to verify that that is the case. Looking here at our VIF scores, we see that all of these scores are under 5, so we can be confident that multicollinearity issues are not going to be a main concern in our MLR model. Our highest one is for percent unemployed at 3.785. Again, that's still so low that it's not concerning. We do also see that the LEMAS percent police on patrol has the lowest VIF score, which matches what we saw in our correlation matrix, right? We had the lowest strength correlations with that variable. So seeing a 1 there is not surprising. And we're just going to move forward with our MLR model, confident that multicollinearity issues are not going to be a concern.